In this lesson, you will find measures of angles inside or outside a circle. The warm-up. 2x, I lost it. So for the warm-up, 2x equals 84 plus 32. 84 plus 32 is 116, divided by 2 is 58. And for my next problem, 360 minus 120 is 240. 1/2 of 240 is 120. For this problem, 1/2 of 2x plus 4 plus 28. So simplify this a little bit. That would be 180 minus x equals 1/2 of 2x plus 4 plus 28 is 32. So 180 minus x equals 1/2 of 2x is x. 1/2 of 32 is 16. I add x to both sides. I get 2x over here. 180 minus 16 is 164. And 164 divided by 2 is 82. And then for the last problem, 1/2 of the measure of an angle. 1/2. So I'm going to call that angle A. Angle plus the measure of the angle's supplement. So the way to get the supplement is you would start from 180, subtract A, and that would give you the supplement, is equal to the measure of the angle. Find the measure of the angle. So 1/2 of A minus A is negative 1/2 A plus 180 equals A. If I add a half to both sides, that's like 180 equals 3/2 A, or 1.5. 180 divided by 1.5 is 120. You know that the measure of an inscribed angle is half the measure of its intercepted arc. We learned that before. This is true even if one side of the angle is tangent to the circle. So even still here, this is still an inscribed angle because its vertice sits on the circle. So angle 1 is 1/2 of arc AB. The measure of angle 2 is 1/2 of the measure of arc BCA. I'm going to actually use that now to see how that works. So the measure of angle 1 is 1/2 of 30, so it's 65. The measure of arc KJL is 2 times the inscribed angle. 2 times 125 is 250. And we can do this guided practice. So this measure of angle 1 is going to be 1/2 of the arc. 1/2 of 210 is 105. And on this one, the measure of RST. So 98 is going to be 1/2 RST. 98 times 2 is 196. And number 3, they want me to find the measure of arc XY. They mean that one because they want the minor arc. There's not a third letter to do the major arc. So 80 times 2 is 160. Two lines intersect a circle. There are 3 places where they can intersect. They can intersect on the circle, which we've learned about inscribed angles. They can intersect inside the circle. They can intersect outside of the circle. We're going to use theorems 1012 and 1013 to find measures when the lines intersect inside or outside the circle. So if two chords intersect inside a circle, then the measure of each angle is 1/2 of the sum of the measures of the arcs they intersect. So I would take the measure of arc DC and AB, okay? And I would add them together and take 1/2 of that. And that would be the measure of this arc and the measure of that one because they were congruent. If I wanted to find the measure of angle 2, I would be taking 1/2, I would be taking AD plus BC, 1/2 of that, so basically the average, and that would be the same for those two. If a tangent is secant, two tangents or two secants, so basically if two lines intersect outside the circle, then their measure of the angle formed is 1/2 of the difference of the measure of the intercepted arc. So if I want the measure of angle 1, I need the measure of arc BC, the measure of arc AC, and I need to subtract them. We're now going to look at this in some problems. So, find the value of x. So when these lines intersect here, and I want to find this angle, it's JK and JM. Arc JM is 130 degrees. Arc KL is 156. So they skip a step here. I'm just going to go through it with you. 130 plus 156 is 286. Divided by 2 is 143. Okay? And find a measure outside a circle. So this is where we're going to subtract 178 minus 76 equals 102 divided by 2 is 51. There is another problem here that goes through the northern lights. This is a very involved problem. It talks about how the northern lights flash above the earth and finding the measure of these values so that you can then find the measure value of this arc. And it involves trigonometry. I have done this problem in a separate video called Geometry Northern Lights. Complicated problem because they leave out some information. They want me now to find the measure of this arc. But I do not know the angle measure here. So I'm actually missing two things. But if this is 102 degrees, this other angle here would be 180 minus 102. So that would be 78 degrees. So 78 degrees is going to equal 1/2 of 95 plus y. If I multiply both sides by 2 to clear that 1/2, 78 times 2 is 156 equals 95 plus y. 156 minus 95 gives me 61. So that arc y is 61 degrees. For the next problem, I want to find A, which is the measure of arc FG. Since they intersect, and since these are actually two secants, intersect outside of the circle, I know that 30 degrees is going to be equal to 1/2 of the difference of the arcs. So A minus 44, 1/2 of that is equal to 60. I'm going to multiply both sides by 2. I just said it's going to be equal to 60. It's going to be equal to 30, but I know that 30 times 2 is 60 equals A minus 44. I'm going to add 44 to both sides. and I would get A equals 104. Now this problem is going to bring a lot of things together. Okay, in order to find this, I need to find this, and I'm going to take 360 and subtract that. So in order to find this arc, I need to find this angle, multiply it by 2. Okay, so I'm finding, first of all, I'm finding angle X. I'm going to draw this triangle here. It's a right triangle. This is 3. This has an arc going through it, so while this is 2, this side is 3. So let me redraw this because I think this is a bad drawing that I've made here. So this is 5 and 3, and I want to find angle X. This is a right triangle. If I use Pythagorean theorem, I'll find that this side is 4, and I can use any trig function as if you watch the Geometry Northern Lights problem. But I can see here that 3 is adjacent to X. 5 is the hypotenuse. So I have adjacent and I have hypotenuse. If I use SOHCAHTOA, if I don't remember, I can look and say adjacent and hypotenuse uses cosine. So I'm going to be using the cosine of A is 3.5. 3 divided by 5. The cosine A is 0.6. Remember, this doesn't mean anything. This is not the answer. This is simply what I need to put it into the calculator. When I put it into the calculator and I use the inverse ratios, I'm basically saying have a triangle, right triangle, and I have an angle in that right triangle that has a cosine ratio of 0.6. When I ask for the inverse cosine, and I get 53.1, so that's going to round to 53 for that angle. That's saying when I have a inverse, when I have a cosine ratio of 0.6, what angle does that equate to? Inverse cosine is saying what angle measurement does that equate to? And it equates to 53 degrees. If this is 53 degrees and this is 53 degrees, this red angle, this red arc, the measure of arc TR is 106 degrees. So if I start at 360 and I subtract 106, I get that the measure of arc, of this arc, TUR, which is x degrees, is 254 degrees. They rounded to the nearest tenth. Which means when they did the problem and had the 53, I used 53 because I would just have you it didn't say what to round to, so I went with whole degree since everything has been whole degree. But if you remember, we had 53.13. So 53.13 times 2 actually would have been 106.26. I know I'm going to get a negative, it's going to be the opposite of that. So that would have been 253.74. So they rounded it to the 10th. I rounded it to the whole number and got 254. It's time for the daily homework quiz. Line T is tangent to the circle. Find the value of x. 230 divided by 2 is going to be 115. For these to find x, 68 plus 36 is 104, divided by 2 is 52. For this one, 72 minus 22 is 50, and half of 50 is 25. Okay, find the value of x and y. So first of all, for angle X. Okay, 27 is going to be equal to 1/2 of 135 minus X. I'm going to multiply each side by 2. 27 times 2 is 54 equals 135 minus X. 54 minus 135 is negative 81 equals negative X. So X equals 81. Now they want me to find Y than other people would, but I can see here that this and this are an inscribed angle that is a measure of 135 degrees, that intercepts an arc that has a measure of 135 degrees. So 135 divided by 2 is 67.5. That's that measure there. So over here, 180 minus 67.5 is 112.5. I actually didn't even need to figure that out. I just realized from exterior angles theorem, I could have done 67.5 is going to be equal to y plus 27. That would have been faster. So 67.5 minus 27 is going to be 40.5. So my X value is 81, and the Y value here is 40.5. And that has been the lesson. Here are the problems from which to do your homework.